I am Krishna Patro, Associate Professor in the Department of Computer Science Engineering, IARE, Institute of Aeronautical Engineering, Hyderabad. Now, we'll discuss about one more important topic, that is linear and binary sets. First, we'll start with linear sets. I told you, searching is one of the important operations in data structure. Searching is an operation or a technique that helps to find the place of a given element in a list. So, if at all you are having a set of items, from this set if you want to find something, that operation is called searching. Any search is said to be successful or unsuccessful depending upon whether element is available or not. If element available, that is success. If element is not available, that is not success. There are different searching techniques are there. Linear search, binary search, Fibonacci search, interpolation search also. So you can find the element using any of the technique. So your ultimate goal is what? Find the element from the given list. Sometimes the element may be available, sometimes it may not be available. If it is available, it is success, otherwise it is not found. This is the simplest of all searching technique. The linear search you can implement in a simplest way. In this technique, an ordered or unordered list will be searched by one from the beginning until the desired element is found. The name indicates what? It is a linear. That means always you have to search from beginning. The name indicates searching from beginning until the desired element is found. Whatever the elements are there in the list, it may be in order or it may be unordered. It may be sorted or it may be unsorted. If the desired element is found, then search is successful, otherwise it is unsuccessful. Okay. So in your day-to-day life, linear search also you are using. Sometimes you may try to search a particular number from the given set of numbers, whether the number exists or not in this. Sometimes while even when the result is published, you have to check whether my roll number found or not in the result. If my roll number found, yes, I pass. If my roll number not found in the result, then I am fail. The time complexity of linear search algorithm. Suppose there are n elements organized in a sequential list or a sequentially on a list. The number of comparisons required to retrieve an element from the list is purely depends on the elements stored in the list or not. If the element is available in the first place itself, then the best time is order of 1. See, written big O. This is called big O notation. Big O. Big O notation. If the element is available somewhere in the middle or after the middle or before the middle somewhere, that means the time required to search using linear search comes under average case, that is order of n by 2. That is also known as order of n. This is also known as order of n only. And the worst case is the time required to search till end. Sometimes the data may be available at the end, so you have to go till end. So that is order of n. Okay. So these are the time complexity of linear search algorithm. Please observe the linear search. Assume I am having a set of item 3, 7, 12, 35, 32, 41, 54. My key value is 54. Whether value 54 found or not. Yes, it is found. So in the 7th location, the data found. So while searching, it is searching from beginning. Please observe. First initial key is 1, is not found. Then go to next location, is not found. Then go to next location, not found. Then go to next location, not found. Then go to next location, not found. It is keep on checking until it found. It will go. Now it is found. Yes. So after 7 comparison, found. So this is the way the linear search works. Always linear search start from beginning. So whatever the key you have given, that key value it is comparing with the available data. First is compares here, then compares here, then compares here, then compares here, then it compares here, then it compares here, then it compares here. When it reaches at this position, it is says yes, your required data found. If for example instead of 54, assume I will give 58. In that case, what will happen? It will go till end, but it is not found. It has reached end, so it will say not found. So this is the way the linear search works. List A in which data is to be searched. Assume you are having a list. List means one type of array. Suppose I want to search 57. 57 available or not. First you have to compare with A of 0. Not found. Then it will go to second location 2. Then it will go to 3. Then it checks whether 2 second position is 2 is not matching. Then go to third position. Then it will go to fourth position. It will be keep on going. Now you see how the searching works. Data not found in A of 2. If it is not found, then it will go to next A of 3. In A of 3 the value is 9, but our required value is 57. So 9 is not matching with 57. So not found. Then it will go to next location, A of 4th location. So in A of 4th location, my value is how much? 11. But my required data is 57. So it is also not matching. So it is not found. Again, it will go to next location, A of 5. So A of 5, the value is 57. It is also not matching. Then it checks next data, 17. 17 also is not equivalent to 57. When it is not equivalent, again it goes to next location, because its goal is check, compare whether equal or not. If it is equal, okay, but here also not matching. Then go to next location, A of 7th location. It compare A of 7th with 57. A of 7 value is 25. 25 also not matching. Then in A of 8th location, the value is 57, which is matching. Yes, search is successful. Like this, the linear search works. So it almost found at the end. So it will be order of n. So this is the way you have to write the program. Please observe the algorithm to search data. My algorithm is written in a simple way, and it follows the Python syntax. So I am implementing this algorithm using Python. I have written a small definition, function definition, linear search with A of n with x. What is that x? My x is the required item I want to check, and here I am trying to find from this array with size of n. If index is 0, of course here it is, you can say independent of language, because the algorithm does not depend on language. A simple way of writing: initial index is 0 and flag also 0. It indicates that I have not found till now. Index always start from 0th location, because 0th location is the starting place of the array. So my total number of elements are n, and the index I have to start from beginning 0. So my index start from here. My required item is x, whether item x is available here or not in this array. While checks, index is less than n. N is nothing but number of elements. 1, 2, 3, 4, 5, 6. 6 elements are there. And the index are 0, 1, 2, 3, 4, 5. Okay. It always compares required data from the every position. If it is equal, then the flag will be 1, then break it. That means no need to repeat the loop. If it is not equal, I should go to the next position. So here I wrote a loop. The loop is repeating now. Loop is repeating now. How long the loop has to repeat? Because I told you it has to start from beginning till end. End means n, number of elements. Till end. If data found, the flag will be 1. If it is not found, then the loop will over. It will come out. When it comes out, by that time what is the value of index? Because initial index was 0. If it is not satisfying the condition, then the index is 0 only. Sorry, the flag is 0 as well as index changing. If flag is 0, then come to else part. So data not found. If flag is 1, data found at the particular position. So this is following the C syntax actually. Because in C you can write printf %d, comma, index. Fine. You can implement same thing using non-recursive way. Non-recursive means you can put in a loop using Python language. Initially, assume you are having array with this element 13, 24, 56, 87, 32, 98, 46. Enter the search element. Which element you want to search? You are reading the data x. Then you are calling the linear search method. When you are calling linear search, it goes here, and you are passing the array as well as x. So after passing this element x, and your goal is to search whether x is available or not, it comes to this place, and this method is now repeating for I in range of length of array. That means the for loop repeats how many times? Until the number of elements exist in the array. Here it compares whether both are equal or not. If both are equal, return I. I means what? The position, the index, at which position the data found. If it is not matching, then the loop will over. By the time complete loop is over, so returns -1. The -1 indicates not found. Not found. So you may ask a question, sir, why -1? Why not -2? Of course, you can write -2 also. You can write -9 also. Whichever is not available in the list. Because -1 is not there in my list. Okay. So here I am expecting that -1 should not be in the list. If it is -1, then you can say it's not found. Okay. Similarly, implementation of the linear search using recursive approach. Same program you can write using recursive way also. Recursive means same program it has to call itself. That is called recursive. See, I am reading an element to search. Initially my array is having these elements. How much? 12, 34, 25, 67, 32, 92, 67 and 45. This is available in the list. Okay. And this element x you are trying to find. So you have to check for first, then next, then next, then next, then next till last. So because my goal is use recursive approach. Earlier I have used non-recursive, that means loop. Now here I do not want to write loop. Here I want to write recursive. Means the same function it has to call itself. So when I am calling, first I am passing my original a, then the element x, then the 0 starting index, then n is the number of items exist in the array. So 4 items I am passing. So here also my array x length, the index as well as n. If the index is less than n, and if I equal to x, data found, then return. Else, if it is not equal, else it has to call again and it has to go to next location. Earlier I have passed 0. L was 0, means index was 0. Now if it is not found, it has to go to next location. That's why I plus 1. I plus 1. So this is calling again, because internally it will be maintaining a stack. Keep on going. First time the I value was 0, index 0. Next time I value 1. Next time I value 2. Next time I value 3. Next time I value 4. Until it found. If it is found somewhere in the middle, then it will stop. It will come back. It will come back. So if it is less than n, if it is less than n, continue. If it is equal to n, that means it has such an entire list. Then it comes here, element not found. Element not found. So this is the way this program works. Okay. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.